Okay, so linear or not nonlinear. There's three types of categories that this fits into. One will be equations, the other will be tables, the other will be visually by graphs. I have the hint here. Equations, you need to look at the exponents. If there are exponents, it is not linear. That was what we discussed. So, does this have an exponent in A? Yes, it has an x. So this is non-linear. What about B? Ben, is this linear or non-linear? Yep, because it has an exponent, non-linear. How about this one, Nick? Yeah, non-linear because it has exponents. How about this one, Jonathan? It is linear. Why? Technically there is exponents, but they're all what? 1. If they're all 1, we're okay with that. Anything bigger than 1, we're not okay. All right, how about A? Tristan, linear or non-linear? Linear. Noriel, linear or non-linear? B? Linear. Bailey? Good. Nick? Linear. Good. Easy to tell which equations are linear or non-linear? Okay, all you do is look at the exponents. Now, when we calculate the first differences, remember we usually start at the bottom, and we would do here bottom subtract top. What do I get when I do the bottom subtract top? Lucas? Pardon? -2. What math would I do up here, Andrew? What would be my next one? Which is what? Tell me which numbers. Good. 6 minus 8, which gives me? Good. And what about the next one, Ben? Very good. Gives me -2. My last one here, Nick, what do I write for that one? 10 minus 12 equals -2. If all of these are -2, Justin, what do you think this will be, linear or non-linear? Linear. Because they're all the same. When first differences are all the same, they are linear. Let's do the next one. Jonathan, what would I do for the next one here? Good, and what do I get? No. Good. What would I do for the next one, Tristan? Good, which gives me? Okay, what do I do for the next one, Noriel? Very good. And how about the last one, Bailey? Good. Is this linear or non-linear, Nick? Yeah. Non-linear because the first differences are not the same. Okay, and then visually you can tell from a picture which one is linear or non-linear. What do you say about A? Pardon? Yes, this is non-linear because it is a curve. Andrew, what about the next one? It's non-linear, even though we have the points. Now, you can draw what with this? What could you draw? Be careful on EQAO because they say draw a line of best fit or a curve of best fit. This one we could draw a curve of best fit. So we're okay with that. But it's still non-linear. How about C, Nick? It is linear. How about D? Justin? Yeah, non-linear. Easy? Linear, non-linear. 3 ways to tell. The equation, the graph, the table. Are we all okay? All right, the next one. Ooh, some big problems here. Or a lot of problems. Determining the equation of a line when you are given a graph. Important things to remember. Here's a big one. The equation of any line is always y equals mx plus b. And I have here m is the slope or rate of the line. B is the y-intercept or the starting point. So those are some very important things that you have to remember. Now I have two formulas to help me out here to calculate the slope. Can someone tell me what is one of the formulas? What's one of them, Jonathan? M equals rise over run. What's the other one? Tristan? Absolutely. You will have to memorize those formulas. Okay, so I'm going to use them. Now, which formula did I say would be makes most sense to use that you won't make as many mistakes like with the other one? Which one is it? Bailey? Beautiful. Y2 over Y1, or Y2 minus Y1 over X2 minus X1. Anyone remember what two reasons I had for this? What common mistakes would we make with rise over run? Nick? Okay, the scale. What else? And the, starts with the D? Direction. Rise over run doesn't tell me my direction. Remember, slope dude, nice negative, puff puff positive. Okay, you have to take that into consideration when you're doing rise over run. So we're going to come up with the equation for this line here. So my first one, my easy one I can figure out here is my B, my starting point. Where is my starting point, Jonathan? Where does the graph start here? Ben? Pardon? Not 1 in 20. It is 15. Why is it 15? Tristan? Yes, because this is going up by 15. So it's saying skip a line 30, skip a line 60. So you could figure out what this skip a line is by doing 30 divided by 2. So this is actually going up by 15s. So right there, I know my starting point is 15. Now I need to come up with my slope. What do I need in order to come up with my slope? Noria, can you help me out? What do I need to use my slope formula? Two nice points. So here's my strategy or my recommendation for you. Look, here's one nice point, and I would write that point as 10, 30. Remember, x goes first, y goes second. Now, I could use this point here. If this is the only other nice point, you have to use it. But I'm going to make the recommendation. You don't want to make a mistake because this isn't actually specifically told to you. It's actually 45, but if you made an error like counting error, you don't want to use that. So I probably wouldn't use this point here. I would go up to the next nice point where I for sure know the values, which is here. And the coordinates of that point is 30, 60. I'm going to label my points x1, y1, x2, y2. And now I need to substitute them into my formula. So, Bailey, what will I write in my formula? Excellent. Nick, what would I write after this? Very good. Lucas, what would I write after this? Yep. So what do you get? 1.5. Even if you get decimals, I want you to change the slope into a decimal. The only time you wouldn't change it into a decimal is if it was a multiple choice question and they don't write it as a decimal. If they leave it as a fraction, you want to reduce it into lowest terms. And I'll review that on the last day, how to use your calculators to reduce into lowest terms. Okay, so m equals 1.5. Now, how do I write this as an equation? Andrew, what would I write for my equation now? My equation has to look something like that. 1.5x plus 15. So I just came up with my equation. Now, Ben, what does the y represent in this equation? I can use my graph to help me out. What does the y represent? Yeah, here's my y-axis, and that's talking about cost. What about x? Nick, what does x represent? Nope. I'm defining my variables. Y represented the cost. X represents, looking at my graph, what is x talking about? So I would write here the number of posters. It's important that you understand what your variables mean because you may be asked a question, so you'd have to find the equation and then use the equation to answer the question. So I've just defined my variables. Now you may see EQAO do something like this. C equals 1.5n plus 15. That's the same thing. You can use any variables you want. It really doesn't matter. Okay? As long as your rate is attached to your x. Okay? The next one here, determining the equation of a line given word problems. You have inside your notebooks a wonderful chart that we came up with telling you all the M words, telling you all the B words. Important things to remember here. M is your rate. It means per. Sometimes each for every. And usually if you see this little dash, that number is always talking about the M. B, it's your starting point, initial value, base fee, y-intercept, starting cost, constant. Those are all the words that mean your starting point. Again, there's a more in-depth note for this inside your notebooks. So I have here, you do not have to use y and x. You can use any variables you want as long as the slope is attached to the variable and the b is the constant. Okay, so I have an example here. A basketball club offers two types of membership. Membership Y, no registration fee, and $15 per hour for court time. Justin, what would I write for an equation for this? Pardon? Why don't you have a B? Yeah. So here it says $15 per hour, so I know that's talking about my slope. So I have here y equals 15x. What about for membership Z, a $40 registration fee and $5 per hour for court time? What would I write for that equation, Jonathan? 5x plus 40. Very good. Okay, and it says here, which of these relationships is a partial variation and what is the initial cost? Partial variation. So Tristan, just looking at this, which one is partial variation, the top or the bottom? Direct means like a direct flight, so you start from 0 and you go up. Partial means you have to start somewhere else. So which first or second one is partial? My starting point is not with the, my starting point is my constant. It is my b. What's my b here, Tristan? No. Okay, that this is something we have to remember because it's so big. So my equation is always y equals mx plus b. M is always my rate. B is always my starting point. Okay, so here my rate is attached to x, so that is 15. What's my starting point here? 0. So this means it starts at 0, so that is a direct variation. This is my rate because it's attached to the variable, 5. This is my constant, so that's my starting point, which is 40. So Noriel, can you tell me which one is a partial variation? The first equation or the second one? Okay, so the second one. So I know that that is membership Z. So right away, I can eliminate what two options, Bailey? I can eliminate A and B. And then now I have to figure out which one is the initial fee. Which one would you pick? Nick? Yeah, that's my starting point. This starting point's always your constant. The rate is always attached to the variable, okay? So that's given a word problem. Again, here we just talked about partial and direct variation. Important things to remember, partial variation, the graph does not start at the origin, which means it does not have a starting point of 0. I'm not going to put that there. Direct variation, the graph is proportional and goes through the origin, which means it goes through 0. So, looking at this, it says, at her fitness club, Joanna's charged $15 per month. The total cost for 12 months is $270. Is the relationship between the total cost and the number of months a direct or partial variation? What is the initial fee? Okay, this is a difficult question. There's a couple ways we can tackle this. At her fitness club, Joanne is charged $15 per month. The total cost for 12 months is $270. So I'm going to write my equation out here. Y equals mx plus b. What number can I fill in right away? Andrew? Yeah, where am I going to put the 15? Yeah, 15 is my m. Now, it tells me that I have to, because this right away, it says, what is the initial fee? I don't know that. My initial fee is another way of saying my B. That's saying I don't know my B. So I actually have to solve for B. But they give me some information. They tell me that the total cost for 12 months is $270. What am I going to do with this? Jonathan? Would what be X? So I'm talking about months and I'm talking about cost. Do you remember which variable is usually always cost? Y is usually always cost. So this is going to tell me Y is the cost, and the cost is equal to $15 per, this is talking about the number of months. So I can plug this information in. So Ben, what would I plug in here? Instead of writing Y, what would I write? Good. 270 is equal to 15, what? Instead of writing X, I can sub something else in there. Good. Now this became a solving an equation. Nick, what do I have to do next? Good. Tell me what that is. Okay, what's my next step going to be, Justin? Good, so what will I write? Equals B. What do I get next, Jonathan? B equals 90. So that's saying my starting point is 90. So Tristan, if my starting point is 90, is it direct or partial variation? Can you read the definitions up there? It's partial. So which ones can I eliminate, Tristan? Okay. And now what would be my answer, Noriel? D. It's partial variation 90. Now, there is another way. Like, this is a difficult question. It's touching on everything. What I would do, like if you really had no idea what to do for this question, can anyone think of how to do this not this way? Lucas? Uh, what does the cost have to equal? What does the total cost have to equal here? Lucas? 270. So I know that if I use this, so this is actually telling me what my initial fees are. So I have four ideas of equations. Y equals, I know it's 15x plus 0. Well, what do I get when I put in 12? Do I get 270? No. Then I would do the next one. Y equals 15x plus 180. What do I get there? Then I would do the next one. Y equals 15x plus 15. Or y equals 15x plus 90. And I would try all four of those equations out with 12 months, because you know it's $15 per month, and see which one actually gives me 270. Does that make sense? A little bit how you're using the answers? That's a good strategy to use. Okay? Our last one here, determining the equation of the line. When we talk about tables, important things to remember. Calculate slope using your slope formula. Determine the starting point. Remember your y-intercept is at 0. Okay, so sometimes when we're given a table, we have to work backwards. So I'm going to start, and I wanted you to tell me, what is my b here? What would I have to do to solve for b? Bailey, can you help me out? Good. Excellent. Okay, so this is going up by tens. So you're absolutely right. I'm going to subtract 10 to get 0. Okay, that's good. Okay, now what do I have to do? Nick, can you help me out? So I've got 0 on this side. What do I have to do? Okay, so how do I do that? Good. So what is this going up by? 75. 75. So now what do I have to do, Lucas? Yeah, I do minus 75. And what do I get that to be? Lucas? Yeah. Which is? Yeah, 200. So I now know, so here's 0 people, and it costs 200. Oh yeah, 175. I'm sorry, I had a brain fart. It would be 100. Thank you. Okay, and then it would be 100. I'm sorry. I think I may have misheard that. Okay, so I get b is equal to 100. Are we okay with that? Minus my mistake? Okay, so I've figured out my starting point. It always occurs at 0. So here's 0. What is it at 0? 100. Okay, now I need to calculate the slope. There's two ways you could do this. We're going to do both ways. Whichever way you remember most. Now, I've always told you y2 minus y1 over x2 minus x1. A little bit longer, but you're going to get the right answer. You can pick any 2 points. So I'm going to pick this one and this one. I'm going to label this x1, y1, x2, y2. So, Andrew, what would I write in my equation here? M equals what? Excellent. Ben, what would I write after this? Good. Nick, what would I write after this? Good. There's my M, 17.5. That's using your slope formula. I would probably do it that way because it's less things to maybe remember. Now, the other formula I can use, does anyone remember how to use it? Rise over run? Nick? What do you do? Okay, but I don't have a graph here. I just have a table. Okay, this is a good solution. If you remember what you could do, this column is talking about your rise. This column is talking about your run. Which one do I think you'll be more likely to remember? This one. But you could do rise over run, which gives you 175 over 10, which gives you 17.5. Either one gives you the same answer. I think you're going to remember the formula one a little bit better. So now I need to actually write my equation. Justin, what will my equation be here? Pardon? Plus 100. Good. What does y represent here? Jonathan? How does it go in my table of values? What is this letter? X, Y. So what does Y mean? Yeah, Y is talking about the cost. What does X represent, Tristan? Good.
Mr. Ladich, please contact the main office. Mr. Ladich, please contact the main office.
Okay, so that's linear equations part 1 in a nutshell. I'm going to be giving you your multiple choice questions. Again, there's 10 of them.